And the method, so I have accepted that we use the fluorescence to study the interaction of protein and lipid. So how can you tell from the fluorescence that our proteins and lipid molecules are interacting? So general characteristics like if our protein and lipid molecules are interacting, we should see a blue shift, which is indicated by a blue curve here. Which means that if our proteins and lipids are interacting, we should see a blue shift, which means shift to the shorter wavelength, and the fluorescence intensity should increase compared to the normal fluorescence, which is indicated by a green curve. And when the protein unfolds or if it's not interacting with the lipids, that means we have a red shift, which is indicated by a red curve. That means we have fluorescence shift to the longer wavelength and decrease in the intensity of the fluorescence. So this is important key point. This will help you interpreting my data that I will show you later on. So when we have a blue shift, high intensity, and shift to the shorter wavelength, that means our protein and lipids are interacting. So my procedures, I have prepared a small unimolar vesicles with a 30% dialyl phosphoryl glycerol and 70% dialyl phosphoryl choline, which means that I have 30% single negative charge on my lipid vesicles. Fluorescence spectroscopy was used to analyze pH-dependent conformation changes. Wild-type bags and mutant K64A were analyzed at a different pH. So these are my results, and I'll be talking about. So this spectra indicates the fluorescence intensity of K64A and bags at a pH 8. Now, in all my data, black curves indicate the wild-type fluorescence of wild-type, and the red curves indicate the fluorescence of K64A mutant. So here you can see that at pH 8 for wild-type bags, there's no difference between ancient spectra, whether the lipid is present or not. The spectra doesn't change a lot. So at pH 8, the fluorescence intensity does not increase with respect to the lipid. While for K64A, you can see that in the presence of lipid, which is indicated by a solid curve, the fluorescence increases when the lipid is present for K64A at pH 8. So this is another spectra that indicates the fluorescence of bags and K64A at pH 6.5. So here you can see that both